Today we are going to be graphing absolute value functions. So our objective for today is going to be able to graph absolute value functions and evaluate them. Okay, so first we need to know what an absolute value function is. An absolute value function is a number's distance of a number from 0 on a number line. And it's important to note that distance can't be negative. We don't talk about distance going north as positive and south is negative, or west is positive, east is negative. Okay, we don't talk about that. We talk about just distance is just a number, positive number. So distance is always positive. So that's what an absolute value function does, is it gives you what is that that number's distance from 0. So if we look at filling in a table, if I want to know what f of 6 is, that would be the absolute value of 6. Here's the absolute value symbol. Looks like that. It's a straight up and down lines. Now, when you're writing it on paper, it's important to note that if I write it that way, it almost looks as 161. So it's always important to note to make those lines longer. So we always make them longer or taller than a standard one or your standard number. So basically I'm looking for the number 6 on a number line. There's my number 6. How far away is it from the number 0? Well, that's 6 units away. So when I input a 6, I get out a 6. So if we were to graph this function over here, if I input a 6, I get out a 6. So 1, 2, 3, 4, 5, 6. Okay. When I put in a 0, f of 0, the absolute value of 0. Well, how far is 0 from 0? Well, that's 0 units away. Okay. What about when I put in a negative 3? The absolute value of negative 3. How far is negative 3 from 0? It's 3 units away. Okay, so if I put in a negative 3, negative 1, 2, 3, I get out a positive 1, 2, 3. Okay. So when I put in a 1, I get a 1, 2, and 2, 3, and 3. Negative 1 gives me a negative 1. Negative 2 gives me a negative 2. So I end up getting a graph that looks like this. Right there. Okay. Looks like that. Okay. Maybe should have used a ruler, but okay, so there's my graph. Okay. A few things to talk about when talking about absolute value is you treat it like a grouping symbol. What we mean by that is you treat it a lot like a parentheses, meaning you have to do what's inside of it first. So if I have the absolute value of 5 minus 8, I take 5 and subtract 8 first. So you do what's inside of here first. I would take the 5 minus 8, which is negative 3. And then I have the absolute value of negative 3, which is 3. Okay, so you treat it like a grouping symbol and that you do what's inside of it first. Just a note of caution though, we don't distribute. Meaning if I have a 3 times the absolute value of 10 minus 8, I'm going to do it in red, meaning we don't do it. You don't do that. That's a big no-no. Okay, we'll put no above it. You don't distribute into an absolute value. Usually, it tends to mess stuff up a bit when we do. So we don't distribute within an absolute value. But other than that, we treat it like a grouping symbol, meaning we do what's inside of it first and then do the absolute value. Okay. One thing, if I was to cover up and just look at one half of this, if I just look at just this half of the graph, this is just a line. This is just a line. It's a line with a slope of, we go up 1 over 1, up 1 over 1, a slope of 1. A y-intercept of 0. It crosses there. It hits this y-axis here at 0. A y-intercept of 0. So I can write the equation y equals mx plus b for this half of the line as y equals 1x plus 0, which we can simplify to just y equals x. But this is just for this one half of a line. This is just for x's greater than 0. Okay, so from 0 on up, or I suppose equal to 0. We could use an equal to there. Okay, but this other half doesn't have a positive slope. This other half over here has a negative slope. Oh, if I would have drawn it right, it goes down 1 over 1, down 1 over 1. So over here, this line over here has a negative slope, a slope of -1. So this graph can be written in pieces, meaning it can be written as a piecewise graph. We have this equation with a positive slope over here and this equation with a negative slope over here. If we finish this left side, y equals mx plus b, the y-intercept is still here at 0. So the equation for this is y equals -x for x's that are less than 0. So over here we had for x's that are greater than 0. We included the equal to over here, so I can't include the equal to over here. Remember, those intervals can't overlap. So an absolute value function actually can be written piecewise. Oh, forgot the S. The E, sorry, can be written as a piecewise function. It's equal to x for x's that are greater than or equal to 0, and it's equal to -x for x's that are less than 0. Meaning if I put in a number less than 0, let's say -5, I would be in this interval. So I would need the negative of -5, which is 5. Which makes sense because -5 is 5 units from 0. So again, it can be written as a piecewise function. Okay, let's talk about some other things here. Domain and range. Again, domain is our x's. What numbers can I put into this function? Or how far left and right does this graph go? Well, it's going to go this way, up that way for forever, and this way for forever. So my domain in this case is all real numbers, which we use the idea of all real numbers so often, we have a fancy symbol for it. It's an R, but with 2 lines here for the R. The range is the set of all the y's, my outputs, if you will, or my up and down. How far up and down does this graph go? Well, these lines go up for forever, but down it stops right here at 0. There isn't anything down here in the graph. So the range for this is positive numbers because it just goes from 0 on up. So my range, I could write it a bunch of different ways. I could say my range is just the positives from 0 on up, or in function notation, f of x is greater than or equal to 0. This is basically just meaning from 0 on up. Okay. X and y intercepts. The only place it ever crosses the x, again, x and y intercepts are where it crosses the x and y axis. The only place it ever crosses is here at 0, 0, which we call the origin. So it has a y-intercept at x equals 0 and a y-intercept at y equals 0. Minimum and maximum. Minimum and maximum, again, is the low and high point. The minimum is the lowest point. The maximum is the highest point. The minimum, the lowest point, it does have a minimum. There's a low. The farthest down it ever goes is 0. So it does have a minimum at y equals 0. Since we're talking about lowest and highest, up and down, that would be the y's. So it does have a lowest point, y equals 0, but a maximum. Does it have a highest point? This graph is going to keep going up like this for forever, so it has no maximum. It has no max, no highest point. Keeps going up for forever. Okay. Where is it increasing and decreasing? Again, we read a graph from left to right. So this graph, again, as I read from left to right, if I was a little person walking on this graph, I would be walking down for this left half. So it's decreasing for all my x's that are less than 0, or it's decreasing for this half. Okay, so because again, it has and that makes sense, it has a negative slope, which tells me it's going down from left to right. Again, we read graphs from left to right, just like we read a book. It's decreasing for x less than 0, but then we would say then it's increasing for x is greater than 0. Notice we don't include the equal to. We had our equal to here, and really the equal to, it doesn't matter which one you use because they both equal 0, 0 at that point. We don't use equal to when doing increasing and decreasing because you can't be increasing or decreasing at a point. Meaning if I had a graph and I said, hey, this point's on the graph, and I asked you, is it increasing or decreasing at that point? Yeah, you don't know. You have to know what's happening with the rest of the graph. So meaning you have to have an interval. You can't do it at that specific point. So it's increasing or decreasing. So there is the gist of our, what we call our just plain absolute value function. And we're going to be referring to this as the parent. So over here, let's go ahead and let's highlight here in yellow. This is what we call the parent absolute value function. And the whole rest of this section is going to be taking this parent and moving him around to create what I like to call the children. Okay, it's like if I move him up, move him down, move him left, move him right, so forth and so on.